Hello and welcome to Global Illumination in Unreal Engine 4. I am Humam Bahnasi. I am a technical artist at Epic Games. I work with the enterprise team in Montreal. For this training, we will start with a simple interior architectural scene where we only have direct lighting and shadows generated by the engine, and then we will learn the different ways in Unreal Engine to generate global illumination to reach a result like this one here. So if we go back to the initial state, we notice that Unreal Engine does a fairly good job calculating the shadows, the direct shading. However, all the indirect lighting information like contact shadows, color bleeding, light bounces are still missing. And for an architectural scene, those terms are important to add the realism to it. So once this all terms combined with textures, materials, and reflections, we will have something like this one here. So let's start by looking at the agenda. We will start first with an intro about the different ways that we can generate global illumination in real time. And in Unreal Engine, we will be covering two main approaches. The first one is baked GI, and the other one is dynamic GI. We will cover both in details later, of course. However, we will be focusing more on the baked GI because it is more common with architectural scenes, since most of the scene is static and it can benefit from the higher quality that baked GI generally has. So as most of you know, simulating GI is a very intensive process. It involves ray tracing that requires sometimes minutes or hours to calculate the final GI. So as most of you might know, simulating global illumination is a very challenging problem. It is a performance-intensive process where it involves ray tracing that requires minutes and sometimes hours to calculate. In real time, the allowed time for rendering the full frame, including GI, is in milliseconds. This is 1/1000 of a second. So the classical or physical simulation approaches doesn't work with real-time engines. On the other hand, in real time, there are two main common approaches for calculating global illumination that we mentioned before. The first one is pre-calculating or pre-processing GI and storing the result in what is called light maps. Those light maps are basically textures that blended later with materials and other types of textures to give the final results. The main limitation with this technique is that the objects lit with this approach needs to be static. However, the advantage on the other hand is it is very good for performance because we are doing the lighting and the GI calculations in advance instead of doing it in runtime. The other approach for calculating global illumination in Unreal is based on a technique called light propagation volume. Since this approach processes everything on the fly and nothing is processed in advance like the previous approach, the GI is more approximated and generally has much less details than the first approach, mainly to compensate the extra cost on performance. So let's start first with the baked global illumination approach. This is a high-level checklist of the points that we need to make sure we have properly set up in our scene in order to bake light maps. So this is a checklist of all the points that we need to address inside the engine in order to bake global illumination to light maps. I'll go through each one of those points in details inside the editor directly. So this is the interior scene that we will be working with today. And the first point we have is we need to make sure that all our mesh actors are set to static. This is the way that we tell the engine, okay, those objects won't be animated or moved during runtime, and they can receive light maps. To do this, each one of the meshes we have in the editor has a mobility setting that can be either static, so that means that this object won't be moving and can have light maps, or it can be movable, and in that case the engine won't be able to bake light maps for this object because it's going to be either animated or moved in runtime. And there is also a nice indicator in the word outliner that tells us if this object is movable. If you look at this small orange circle in the top corner, that only shows when it's movable. If it's stationary, it will be a yellow circle. If it's static, it won't have it. So that's a nice way to tell from the word outliner if an object is static or movable. In my scene, all the objects are set to static, so I'm good on this point. Now for the next point, I need to do the same, but with lights. So I'm going to search for all the lights in my scene. And I can see here like most of them, or actually all of them, are set to movable. When lights are set to movable, that means the engine will calculate all the lighting information in runtime. So shadows, shading, everything will be dynamic and will be calculated each frame. This is useful if the light is going to be moved or is going to have some animated parameters like color or intensity. But in my case, I need to bake everything to light maps. So I'm going to switch this from movable to static. When I set it to static, I can see that the engine added this preview text on my scene to tell me like the lighting information I have now is not accurate. It's not representative of what's going to be after baked. So this is a preview. I need to bake to see the final results. There is also another option which is kind of mixed between static and movable, and it is stationary. When I set the mobility of a light to stationary, so part of the lighting calculation will be done in runtime, mainly the direct lighting, direct shadows will be calculated every frame in runtime. Only the indirect lighting information or the GI information will be baked. So this is something in between. With this one, everything will be dynamic. With this one, everything will be baked, including the direct and indirect lighting information. So now we are done setting the mobility for the objects and setting the mobility for the lights. The next thing we need to take care of is we need to have a UV channel on our objects that is going to be used for baking light maps. And the reason for that is because basically light maps are represented as textures, and like any other texture, we need to have a UV channel to map that texture to the mesh. So if I open this static mesh in my static mesh editor, ideally what should I see under the UVs is two channels. The first channel will be used mainly for regular textures like diffuse or normal maps, roughness maps, whatnot. And the other one will be specifically used for baking light maps. With this one, we are not allowed to have any overlapping on the UVs, otherwise the baked lighting will be overridden and we will have some lighting corruptions and artifacts. And also it's important to have the least amount of wasted areas around those UVs. So we can create both UV channels in our favorite DCC. However, Unreal offers a nice feature that allows us to auto-generate this UV channel without having to manually create it outside Unreal. So to do this, under the build settings here, we have an option that says generate light map UVs. So I just need to enable that and apply the changes for the engine to calculate the packing. There is also other few parameters that I control, so I can control in which UV channel I want the light map UVs to be generated. In my case, it's going to be on channel 1, that's why I see it here, but I can change that to any number if I want. And also I can change the resolution, the packing resolution. This is not controlling the baking resolution, it's only for generating the UVs, and ideally this should be matching the baking resolution. So here, this is the baking resolution and it's set to 128. Ideally I should have this set to the same value so I can get correct padding between the UV islands and whatnot. Okay, so now we are ready to bake the light maps. In Unreal Engine 4, the tool that takes care of baking light maps, calculating the global illumination, integrating the results into our materials and everything is called Lightmass. Lightmass is basically a standalone application that supports ray tracing for having most of the global illumination features we see in other ray tracers like V-Ray or Mental Ray. And it supports also distributed rendering over network or multiprocessors to accelerate the baking time. And the way we execute Lightmass inside Unreal is basically under the build menu. If we expand it, we have a build lighting only. So once we click this one, this will send the scene to Lightmass, and it will start calculating the lighting, the GI. After it's done, it generates the textures, import them back into our scene, and integrate everything to the materials. Usually this process takes some time, like a few minutes, sometimes maybe more. So I'll pause the video and get back in a minute once it's done. Now once light mask finishes baking the light maps for our scene, we can see the results directly in the viewport here. Obviously the results are not very good in terms of quality, but we will fix that shortly after. Now, in order to easily improve the quality of the light maps that we bake, it's useful to be able to isolate the lighting information and see the results that have been baked without having all those textures, materials, and other post-process effects added on top of it. So one few things that I usually do in the editor when I want to visualize the light maps and start improving the results by tweaking different settings. This first is I switch to lighting only mode, so I don't see all the textures and reflections and everything, because when I have this mode, I have many visual information that distracted me from focusing on light maps quality. So I always switch to this mode, and I tend also to disable certain post-process features. One important feature I usually do disable is the screen space image occlusion, because what happens is light mask is already calculating some image occlusion terms for us, and it's baked on the light maps, and the engine is also doing another screen space image occlusion that is added on top, so it's confusing to tell which is the good quality and which has some bad qualities, and in order to tweak it later. So it's always useful to disable this, and you can tell now there is some difference after I disable it. So this is the information, the AO that's been calculated by light mask, not the screen space. Also, other useful things I tend to disable is exposure settings. I don't like to keep it to automatic, because that will change the exposure dynamically when I'm looking at some bright areas or dark areas. So I tend always to set it to a constant value, maybe 0, and you can tell, okay, that's too much dark, so let me increase it to maybe 3. Yeah, I think that will be better. And the other thing, also bloom, that can add some highlights to the lighting, which can confuse also with the baked information. With all those disabled, now I can focus on setting the quality for the light maps and doing other bake to improve it. Now, how to improve the quality or the baking time? There is a few things that we can do. Some of those improve the quality, some of them also improve the baking time. So we will go through each one of those in the editor directly. So the first thing is importance volume. So what is this? Basically, it's a special volume, a special actor here that we can get from the editor actors. So if I search for importance, I can get this light maps importance volume. I think I already have one in the scene here, so let me make sure. Yes, I have one. And basically this is a regular volume. If I zoom out, it's the highlighted box here in yellow. And what this volume is useful for is basically tells light mask where to focus or where to concentrate all the calculations in. So when I have big scenes with vistas like this one here, I don't really care for light mask to calculate GI or do any global illumination on these areas. What I care is only my actual scene. So this volume tells light mask where to focus its calculations in. So it's always useful to add this, because it helps first improving the quality. All the bounces, all the ray tracing will happen within that area instead of being scattered all across the world. Also, it's useful for decreasing the baking time. So it has two benefits, and I highly recommend you add it when you want to bake light maps in Unreal Engine. The other useful thing also, which is specifically for interior scenes like this one, is something called light mask portals. It's also another special type of actor, which is this one here. So when I add it to my scene, it looks like something like this. And what ideally I should add those type of portals around all opening in my interior scenes. And what this does is basically it also tells light mass where is my openings in my scene, so it can focus more photons or more rays inside my scene to give it better lighting instead of just scattering rays or photons everywhere in the scene. So for this case, I should have something for this window here, covering it approximately, like a scaling like that, maybe. And now, when I bake light maps, all the rays, like from my sun factor, from my sunlight, will come from inside, and they will be more concentrated. Most of the rays or photons will be coming through this portal here inside my room to get better lighting. And of course, the baking time also will be better because we are concentrating, we are getting most of the photons inside instead of letting them scattered and wasting time on areas that we don't really care. Now, those are the two things that we need to add to our scene. Now, there is many other places where we can also control the quality. The easy and the most fastest way to improve the quality of light mass is through the lighting quality settings. So we have 4 quality settings. By default, it's set to preview. And this is super useful when we iterate on lighting. So when we are changing lighting colors, moving things around, it's always nice to have fast baking times, regardless of the quality, of course, because now we see that there is many issues with the quality of the baked lighting. But it's good because it bakes the scene in a very fast way. Once we are done and we are decided with the lighting setup we have, we can switch it to high or production. And at that case, light mass will take much more time, of course, to bake, but most of the artifacts we see now here, they will be fixed. So let me fastly set it to high and do a bake. And since it will take more time, I'll pause the video and get back in a minute. Okay, so we are done now baking light maps at a higher quality setting. We can notice like most of the small artifacts, the obvious one around the TV and the corners here, are better now. Of course, they are not perfect, but we can improve them even more. So obviously this is not too much to control. So if we want to fine-tune the settings for light maps, we can do this through the word settings. So if we show the word settings tab here, we see like we have a section for light mass and light mass settings. Enabling this, we find much more settings that we can control to have better control on each of the light mass aspects. I'm not going to go through each one of those individually because it will be out of the scope of the time of this training. So I'll focus on the most important ones for the quality at least. So the first one that affects the quality directly is indirect lighting quality. By default, it's set to 1, and we got this results. But if we feel it's not enough, we are still seeing some spots like we can notice in different areas. We can try increasing this. Obviously, increasing it to a higher number, it will also increase the baking time. So let's try it with 5, for example. Also, like if we feel like the lighting is dim, we don't have enough bounces inside the scene, we can increase that by increasing this value here. So this is determine the number of indirect lighting bounces by default. It's not by default, sorry. By default it's set to 3. It's already raised to 7, but we can increase it more. And also we have another individual lighting bounces for sky. So we can increase this if we want. Usually the light bounces, it doesn't add that much to the baking time. It adds for the first few bounces, but after that it will be very small extra increase of the baking times. The other also important parameter in those settings is the static light level scale. By default it's set to 1, but if we feel that we are not capturing enough details like especially for the contact shadows, and we are only getting very large shadows everywhere. We are still missing those small contact shadow details around our objects. We can decrease this value. Be careful when we decrease this value. We will get probably more noise, especially if the quality is very low. So decreasing this value, we might need to increase the quality, the indirect lighting quality, to eliminate the noises that we get from the GI calculation. And obviously this will increase the baking time. So if I'm setting this maybe to 0.05 to get even more details, let me set this to 10. I'll do another bake and see the difference. So I'll pause the video. So LightMask also supports neat feature which allows us to use textured objects as light sources. This is really nice. So if I go back and try this in our scene, let me first switch to lit mode. And let's say I want to have this TV running and have something on it that is affecting the lighting of my room. Increase the exposure a little bit. So for doing this, I'll add a plane very fast. This is a hacky way for doing it, but for time constraints, I think it should be fine. So I'll roughly place this around my TV screen. Yeah, I think that's good enough. Now I'll create a material for this object. I'll go and place it here on the root for now. I'll name it TV cat. And what I'll do, I'll basically just plug a texture directly to this one. I'll plug it to the emissive, and I'll set the material to be unlit. And I need to assign a texture, of course. Let me first import a texture. Import, I think I have textures. Let's try this one over here. Okay, that looks good. And let's apply the material to the plane. Oh, I think we need to rotate it. We have it. Scale it back. Okay, looks good. So now this object, what we need to do with it is we need it to be as considered as a light emitter in LightMask. So to do this, when we select the object, we scroll down to the LightMask settings under lighting, the lighting section, and we have a parameter that says use emissive for static lighting. Enabling this option will tell LightMask, okay, use this as a light source, take the color information that its material have and that is connected to the emissive port, and use it as a light source. I can also control the boost. So let's say I want it to be very contribute too much to my lighting, to my indirect lighting and direct lighting. And yeah, that's all what we need to do now. The next thing is just to bake it. Okay, so we are done baking the light maps with the new TV screen on. And to be able to, we already noticed that we have more light now coming from the screen, like a bluish tint. But if we want to see it easily, let's switch back to lighting only. And we can see how all the blue tint is coming from the screen and affecting all my room here. So it's a very cool feature. We can try it with another texture, of course. So I think I have this one with a different tint. I'll plug it to my material, save it. Of course, now nothing is updated because I need to bake my lighting again. I'll do that very fast. Okay, so now the baking process is done, and we can see now by just changing the texture of the TV from a blue tinted texture to our orange tinted texture, everything in our scene is affected by that color. So we can see the orange tint all across the room. So it's a very nice way to have these kind of effects. Maybe in my case it's a little bit strong, so I need just to go back and reduce the emissive boost to something less than that. But you got the idea. It's really easy to set up, the quality is really good, and it gives us more integration to the scene. Okay, so now we are done with the first approach, which is the baked global illumination, and we are ready to look at the other approach in Unreal, which is dynamic global illumination. As mentioned earlier, this approach is based on a technique called light propagation volume. It has few positives and negatives. The most important ones on the positive side, it's a runtime solution. So we don't have to bake anything or pre-process. Everything happens on runtime. And because of that, animated objects or anything that can need to be moved, it will handle with the same system. We don't need other extra systems to handle those special cases. Everything handled with the same approach, same technique. On the workflow side, we don't need any extra preparation for our models, so we don't need extra UVs, for example. Just have the object in your scene and that's it. They will work out of the box. On the negative sides, the main negative is the cost of the performance. It's more expensive to render, and because obviously this is happening because we are calculating all this GI in runtime every frame, and because we need to render at an interactive frame rate, those calculations need to be highly approximated. We cannot afford doing accurate GI at interactive frame rate. So generally the results from this technique is more approximated or have less quality or less details from the previous approach, which is baked GI. So let's take a look at this, how to use this system in the editor. So first thing, we need to enable this feature from the console variables ini. So going back to my config folder in my engine installation, there is this file here, console variables. I need to open it, edit, and I need to add a custom command here. So the command that I need to add is r.lightPropagationVolume equal to 1. That's all what I need to add to this file. So of course I need to save it, and now I need to restart the editor. So I'll close it. And before starting it again, I'll do a small hack to clear the baked lighting information, so we have a scene without any lighting information to start with. So I'll go to my project, content, maps, and I'll delete the build data for my level. Okay, now we can start the editor. Okay, good. So we see now we have all the baked information is not there anymore. It's cleared out, and we got those preview warnings on the meshes. So we are ready now to enable the dynamic GI. Now in the editor, to enable it, the next step is we need to have one directional light that is set to movable. So I'll search for all my lights. I'll get my directional light, and I'll change its mobility from set static to movable. That's good. Now the next step is we need to enable indirect lighting calculations on that light. The way we do this, there is a parameter here which is called dynamic indirect lighting. So enabling this, we can see directly how the light bounces shows in the scene. So if I go back here, I can see now everything. Maybe it's that the exposure is too much high. Let me try lowering it a little bit. So, and we can see like some of the color bleeding that's coming from the red couch visible on the wall here, and some of those also on that wall. So yeah, we can see a bit of light bounces and GI. But again, if you compare this result to the previous one, to the baked approach, it's much highly approximated. All the small details, the small contact shadows are not there. So with this mode, it's a good idea to enable back the screen space AO to give us those extra missing details. But the cool thing about it, it's really dynamic. So if I decide to move an object, I can see like it's fine, like everything will get updated. I think this bounces is coming from this one here. Yeah. And now for controlling the settings of the quality settings and the performance settings of the dynamic GI or the LPVs, we need to go and find the post-process volume. I think this is the one we use for that scene. And under the rendering features, we will have a section for light propagation volume. So all the settings for controlling this feature, the dynamic GI, is here. So some of them are self-explanatory, like the intensity. We can increase the intensity of the dynamic or decrease it. The size is useful. This is basically controls. It's similar to how light mass importance volume work, but this is for LPV, so it specifies the area or the size where we need our dynamic GI to be focused or calculated. Ideally, we should have this covering all the area we want. So in that case, maybe it should be less than that, because when we reduce it, we will get more details or more quality within the small area we have. So we don't have like bounces going from this object far away until like the end of the room. And also we have some advanced settings here, like for example the bias, light injection bias and occlusion bias. So those bias settings are useful for controlling lighting leaks sometimes, because this is a very highly approximated approach, so we might notice some lighting leaking from behind the wall or from the ceiling and whatnot. So we can play with the bias parameters to fix those type of issues. But yeah, this is a very general overview on how this technique works. Feel free to play with the settings. It's fast because it's in runtime, so it's very fast to iterate and try different things until you get the results that is good for the scene, compared to the previous approach where we need to wait until the light mass peak and we see the result. So yeah, feel free to play with it.